Hi guys, today we're going to get started on ratios and proportions. So first, let's start talking about what is a ratio. A ratio is a comparison of two numbers by using division. So let's jot that down. A comparison of two numbers by using division. But you got to watch out, because think about it. When you use division, what's the one thing that you cannot divide by? There was one thing that you've learned that you cannot divide by, and that thing is a 0. So you cannot have a denominator of 0. So if you try to do this with your calculator, take any number and divide it by 0, it's going to say error on your calculator, and what kind of error message depends on what kind of calculator you have, and that's because this is totally undefined. All right, so for example, let's say there are 10 girls and 12 boys in my class. We're going to talk about ratios here. We're going to compare these two different numbers with division. Now, they don't always write it as a fraction, though. Sometimes they write it in two other ways that I'm going to show you here in just a moment. But let's first start with the division. So we have 10 girls, we have 12 boys. So what we can do is take girls and divide it by boys. And that's what we talked about, a ratio, and it has division in it. And if we were using that example, we'd have 10 over 12. And I want you all to always reduce. So 10 over 12, both have a factor of 2, and we get 5/6. Okay, but they also write it two other ways. I know that might seem kind of confusing, but that's just how it goes. The other way that they do it, girls, colon in between, and then boys. And you're going to do the same exact thing with this. You're also going to do 10 to 12. And if you thought about that as a fraction, they both have a factor of 2. So I would also like you to reduce this one. Just makes it easier. And the last way that they could possibly do this is they could say girls to boys. Now if they do girls to boys, you're just going to say 10 to 12. And again, I would reduce this as if it were a fraction. So this would end up being 5 to 6, like that. All right, so those are the three different ways that you're going to see it written. And do remember always to reduce. We just talked about that. Make sure you do reduce. All right, so on the next part, to simplify a ratio, we first need to make sure that the units, are the same, and then we can reduce our fraction. Okay, make sure the units are the same, and then you can reduce the fraction. It's easier to convert from a large unit to a smaller unit. Now, you can go the other way, but I've noticed over the years that that is the easiest way for students to do it. So I'm going to do it that way whenever we do these problems. And there's a couple of conversions you might not know. You should know them, but you might not know them. You should know them after today, though. So 12 inches are in a foot. 100 centimeters are in a meter. It's a whole meter stick. There are 10 millimeters in a centimeter. There are 1,000 meters in a kilometer. And there are 3 feet in a yard. Okay, you might need those whenever you do your practice with this. So let's look at number 1. First thing you ask yourself, do we have the exact same units going on? And here we do. We have centimeters on the top and centimeters on the bottom. So we can go ahead and reduce this fraction. So 6/8, they both have a factor of 2 in them. So when we reduce, we get 3/4. And I like to just write the word next to it, kind of a reminder that I know I have everything with the same units. Okay, so only thing we had to do there was reduce it. Nothing else. Let's look at number 2. Do they have the same units? No. Inches and feet. Okay, so it says it's easier to convert a large unit into a smaller unit. So what's bigger, an inch or a foot? Foot is bigger. Well, how many inches are in a foot? 12. So if we multiply this by 12, we can convert the denominator into inches. So we'll have 3 over 24, and now everything is in inches. But don't you leave that answer. The reason you don't leave that answer is because it can be reduced. So 3 and 24 both have a factor of 3 in them. So we would do 1/8, and then I like to write inches right next to it right there. Okay? I'm going to have you guys do number 3 and number 4 on your own. So have those ready to go for class, and then we'll go over them there. So do make sure you do number 3 and 4. All right, so let's move this down. We can also use ratios and word problems. Okay, in a first grade class, there are 6 kids coloring with red crayons, all right? There are 3 kids coloring with blue crayons, and there are 9 kids coloring with green crayons, and finally, oh my gosh, a lot of crayons, there are 6 kids coloring with purple crayons. Okay, I'm just kind of circling those and squiggling those just to make it easier on myself. Okay, so let's look at number 5. Red to green. That's how you would say that, by the way. How many were red? Well, let's look up here. 6 kids were coloring with red. So 6, 2, and then let's find out green. Looking for green. Here it is. It's a double underline. That's 9. And I do want you to go ahead and reduce that. There's a factor of 3 in both 6 and in 9. So this would be 2 to 3, like that. Let's look at number 6. Blue to the total. Well, first let's figure out how many blue there were. And right here, this little squiggled line, there were 3 blue. Total, I don't know. They didn't tell us the total. How can we find it out? Well, we have 6 with red, plus we have 3 with blue, plus we have 9 with green, plus we have 6 with purple. And when we add all of these up, we get 24 as our total. Now I want to let you know right here, if I'm moving too fast for you, like you're scrambling to write, you can just listen to me, pause it, then write everything down. I'm just letting you know that you always have that option. So I'm never going too fast, hopefully, for anyone, because you could just pause it. So blue to total is going to be 3 to 24, and then you do want to reduce that. So there's a factor of 3 in both 3 and 24, so this is going to be 1 to 8. All done. And I'm going to have you all do number 7. So please have number 7 done for class when I see you. All right, moving on. So let's go ahead and go to the back side here. You can probably hear me flipping my paper here in the background. In the diagram, DE to EL is 3 to 2, and DL is 40 centimeters. Find DE and EL. Oh my gosh. Okay, this is really weird. I don't even see a variable, right? So let's go through these bullet points here. In other words, 3 to 2 is a ratio that compares the 2 pieces of the segment to some unknown value that you have to find. So notice that it's comparing it to some unknown value. You don't know that. That's going to be your x. So we'll talk about that in just a moment. In order to do that, label your pieces and call your unknown number x. So this is going to be step number 1. Okay? Step number 1. They said DE is 3. So here's DE, and we're comparing it to some unknown number. So it's going to be 3x. X is our unknown number. Then we have EL, and EL is 2. So right here's EL, and we're comparing that to some unknown number there. Finally, they're telling us that DL is 40. So in my picture, I'm going to label this whole thing as 40. There we go. So let's look at step number 2. Substitute these numbers in and solve. Well, what is that about? Substitute what in? Well, let's look at this. This is segment addition. We've already learned that in class. We know that DE plus EL equal DL. Little piece plus little piece gives me the great big piece. Well, DE is 3x, and EL is 2x, and DL in our picture is 40. Now we've substituted it in. So now here's where we'd solve. 3x plus 2x is 5x. And then that's 5 times x. The inverse of multiplication is division. So if I divide both sides by 5, I'll get 8. Now look at this last step, because this is where my students usually kind of, mess up. And I don't want you to mess up. Don't forget to go back and actually answer what the problem is asking. So go back. Look at number 8. Find DE and EL. Okay, we haven't done that. We've just found x. Well, what is DE in the picture? Look up here. DE is 3x. Well, don't we know what x is? We just found it right here. X is 8. So 3 times 8 is 24. So there's DE. And then the next thing we have to find is EL. Look at the picture. EL is right here. It's 2x. So we could do 2 times 8, and that gives us 16. Now, some of you would have gotten the 24, and some of you would have just subtracted 24 from 40 to get 16. And that's completely fine and it's completely right. So if you want to do that, that's fine. If you have no idea what I just said with that, you don't need to worry about it. You can always go through a substitution like this and solve. Okay? So like I said, remember, you can always pause, rewind, rewatch, do whatever you need to do to understand this problem, because this one you guys are going to do and have ready for class. All right, so go ahead and try that one out and bring that on into class. Let's go on to number 10. The perimeter of a rectangle is 42 inches. The ratio of the length to the width is 5:2. Find the length and find the width of the rectangle. So, well, first let's think about the perimeter of a rectangle. Okay, so here's our rectangle. This is a length, this is a length, this is a width, and this is a width. And when we find perimeter, that means add all the sides. Add all the sides. So if we look at this picture right here, it's W plus L plus W plus L, right? So I'm going to write it above here. W plus L plus W plus L. Well, W plus W is 2W. And L plus L is 2L. So the perimeter of a rectangle is going to be this right here. It's what you're going to use. Well, let's look at what they said. The length to the width is 5:2. So length 5, width 2. But remember, this is a ratio, and it's comparing these two numbers to some unknown number. And so we have to put our x on it like that. Now let's substitute it into the equation. First, what's the perimeter of the rectangle? Did they tell us? They did, right here. It's 42. So 42 equals 2. What is W? Over here, it's 2x. Plus 2. And then what's L? Over here, it's 5x. Just like that. So now let's keep working out this equation. 2 times 2x is 4x, and 2 times 5x is 10x. And then once we add those together, we'll have 42 equals 14x. That's 14 times x. The inverse of multiplication is division. So 42 divided by 14 is going to be 3. Now we're not done. Find the length and the width of the rectangle. So if we have to find the length and the width of the rectangle, we have to take this x and we have to substitute it back in over here. So this is going to be 5 times 3, which is 15 for our length. And this is going to be 2 times 3, which is 6 for our width. So this one's just like the other problem, except we're using a rectangle here and we did it before, okay? Go ahead and move on to the next page here and we talk about proportions. A proportion is using two ratios that are equivalent. All right, two ratios that are equivalent. So look, A over B is a ratio. C over D is a ratio. The equal signs means they're equivalent, because that's what equivalent means. And to solve these, what you're going to do is you're going to cross multiply. So if we were going to start solving this problem over here with all these letters, cross multiply means you take the top, which is A, and multiply it with the bottom of the other ratio, which is D. Take the bottom of this one and multiply it with the top one. So we'll have A times D equals B times C. Now we can't go any further with this because way too many variables are there. But this is how you're going to start all of your problems below. So let's move this down. And let's just do number 11. So we're going to have 2 times x equals 3 times 10. So we'll have 2x equals 30. Divide by 2 and get 15. What I would like you to do is try number 12 on your own, and I'll do number 13 and number 14 in class with you. Thanks. See you in class.